Now guys, welcome back to part 2 of our video on finding lengths in right triangles. Yay! Now, we're still going to be following the flow chart that we did in the previous lesson, or in the previous video. So make sure if you haven't checked out video 1, you check out video 1 so you can see how we go through our flow chart. Now, when we go to examine our problem, first, do we notice how many sides did they give us? Yes, Malik. They've only given us one side. Now, when you're given one side, that means we need to be looking for special right triangles. Special right triangles. Is this a special right triangle?
Yes.
Yes, it is. And which one is it?
It is 30, 60, and 90.
We have the 30, the 60, and the 90. So this is, yes, a 30, 60, 90 triangle. Now, notice again, just like what we talked about in our flow chart, we found we had a right triangle. We've said it had one side. It's a 30, 60, 90 triangle. Therefore, we need to label it with its general lengths, the general lengths right here. So let's go through and do that. Across, I like to start with the shortest side first. Across from the 30 will always be 1. Across from the 60 is always the square root of 3. And across from the right angle, which is our hypotenuse, is always going to be 2, like so. Now, for any 30, 60, 90 triangle, this will be the case. Now, just because x is the vertical line now doesn't mean in future examples every time the vertical line is going to be 1. You're looking for what is across from 30, what is across from 60, what is across from 90. If we took this triangle and spun it around, those ratios would still remain the same. The 22 would still be with the 2. The x would still be with the 1. And the y would still be with the square root of 3. It doesn't matter if it's upside down, reoriented, or anything like that. Let's set up a ratio now, proportions, because we know we're going to need proportions for special right triangles. So let's set this bad boy up. Now, just like in our 45, 45, 90 example, I like to color code these. On the top, I'm going to do the original lengths, or our diagram lengths. In the bottom is the numbers from our problem, our specific problem here. So as we go through and look, we know that, hey, let's use the hypotenuse, because notice it has both lengths here. We want to use the one that has both lengths. If we use x and y, you'll notice one is a variable, one is a variable. So we have, like I said, we want to use this one. So we can set up 22. Oh, sorry, that's my bad. It should just be 2. I got caught up there. It should just be 2, because that's the problem, the letter in pink. For the denominator of this fraction is going to be from the actual problem, which that would be our 22. Notice again, that's in black. It's really helpful to color code. If you guys like using those highlighters, I think the highlighters work well too. Now, which variable would you guys like to solve for first? Yes?
Oh, 3.
No, which letter would you like to solve for first?
Y.
Okay, that sounds good. So that means we look at this portion right here, right? We know that y goes with the square root of 3. The square root of 3 is going to go on top, because that's our pink number, and that comes from the general diagram. And then we're going to have y. Oh, thank you, Madison. Let's fix that. Yes, this should be square root of 3, not square root of 2. We just did those 45, 45, 90, so it's got that square root of 3 stuck in my head still. Square root of 3. Because look at that, that square root of 3 goes with y. So we've set up our proportions. All you're doing is looking for these two are grouped together. These two are grouped together. These two are grouped together. Because every 30, 60, 90 triangle is a model of this example.
Yay!
All right, let's cross multiply. 2 times y is 2y. Square root of 3 times 22. One is inside of the radical, the other is not. So we cannot combine them. Is going to be 22 times the square root of 3. Now we need to solve for y here. What can I do to get y all by itself? Anthony, what do you think I'm going to do to get y all by itself? Divide by? Divide by 2. Excellent. Divide by 2. Because that's going to notice that's going to get y all by itself. So we get y equals 22 square roots of 3 divided by 2. Oh, sorry, did I write 22 at the bottom? Thank you, guys. That's why I keep you guys around. Let's give a round of applause to the class, the live audience. All right. Now, when we're analyzing these problems here, like I said, you can combine things that are outside of a radical with outside of a radical and things inside of a radical with inside of a radical. Because both of these lie outside of the radical, we can simplify this portion of the fraction because they're both numbers outside of a radical. What is 22 divided by 2?
That'll be 11.
That would exactly be 11. So it's 11 times the square root of 3 equals y. Great job, guys.
Yeah.
Excellent, excellent. So does anyone have any questions about the simplification of this fraction? When we're simplifying the fraction, things outside of the square root can simplify with things outside of the square root. When they're not, they cannot. Now that we've solved for one of the legs of this triangle, we have solved that leg y is 11 square roots of 3. Let's try and solve for the value of x. So just as a refresher, remember across from 30 is 1. Across from 60 is the square root of 3, always. Across from the 90 is going to be 2. These are the general lengths of our diagram. And this will be true for any 30, 60, 90 triangle. Now, like we said, in the first portion of this video, we just solved for y, and we found out that y equaled 11 square roots of 3. Let's see if we can set up a proportion for x. See if we can set a proportion for x. Now, we're going to use, for the top portion of our problem, let's use the general diagram, or the original, OG. That kind of looks like a G, right? G. And then in the bottom, it's going to be the actual numbers from our problem. Does anyone think they can help me fill in the proportion for x? We need to solve for x. Go ahead, Zainab. We have a guest in the classroom today.
Yeah.
Now, sorry, let me get the correct color pen. Go ahead. 1 and 2. Excellent. X and 22. Great job.
Yes.
Now, you'll notice here, Zainab did a great job of 1, keeping both of the red numbers, or the numbers from the general diagram, on the top and consistent, and then the black numbers and the bottoms from the problem on the bottom. Same line, same information. Great job. Now, you'll notice she did not use the square root of 3 over y, because you cannot solve an equation with 2 variables at the same time. It will not work. So let's cross multiply. We have 1 times 22, which is just 22. We have the lovely 2 times x, which is good old 2x. In order to get x by itself, we would need to divide by 2 on both sides, and we would get x equals 11. X equals 11. All right. So now we have all missing sides in our triangle, and we use both using the proportions of a 30-60-90 and a 45-45-90 in the previous video. Soon we'll be looking at some more difficult examples, as well as a Pythagorean theorem example. And we're still referring to this flow chart over here, whether or not we're given one side or 2 sides. So what I'm going to have you guys do is we have this example right here. What I would like you guys to do is pause the video and then fill in the missing lengths in this diagram. All right, now, before we get to start filling in these blanks, the questions we need to ask ourselves is going through our flow chart. First, we need to see how many sides we are given. How many sides we are given? Not how many sides are we given? We are given one side. So that means we should be looking for our special right triangles. We have two special right triangles. Michelle, what special right triangle are we using? Is it our 45, 45, 90 or our 30, 60, 90? It's indeed a 30, 60, 90. So let's label our general lengths. Does anyone think they can tell me the general lengths here? Yes, Malik.
X is 1.
X is going to be 1. Why?
Because the 30 is across from the 60.
Because across from the 30 is always 1. Yes, Anthony. Would you like to tell us another one? Y is what? Y is 2. And why is that? Why? Because it's across from the square or the 90. Great job. That means our 15 is going to be root 3. Root 3. Great job, guys. Now what I would like you guys to do, I want you to pause the video again and set up our two proportions. Solve our two proportions. All right, now let's set up these proportions. Now we know we're going to need two proportions. I'm going to do them side by side. And then we'll set up and cross multiply. So first, we have 1 over x, because those two are grouped together, over or equals square root of 3 over 15. Those two are grouped together. This would give us our proportion for x. Our proportion for y would be 2 over y equals our square root of 3 over 15. Notice when we set these up that this ratio is in both of them. You need to have the ratio that has both numbers. You can see that right here. In either one of these we have a single variable. So now let's cross multiply and at least get the first one done. We can cross multiply. 1 times 15 is going to be 15. Square root of 3 times x is going to equal x times the square root of 3. Now we know we need to do the inverse of multiplication, so we're going to divide. We're going to divide by the square root of 3. Divide by the square root of 3. We get x equals 15 divided by the square root of 3. Now some teachers may ask you to rationalize this. For our purposes right now, this is a very acceptable solution as long as it is simplified all the way. We cannot simplify 15 over the square root of 3 because, well, 1, the 15 is outside of the square root, and the 3 is inside. So x just equals 15 divided by the square root of 3. What I would like you guys to do, pause the video, and then cross multiply and solve for y for me. All right, let's solve for y. 2 times 15 is going to be 30. Square root of 3 times y is going to be the square root of 3 times y. Again, we need to get rid of the square root of 3. Divide by the square root of 3. Divide by the square root of 3. Because we need to undo multiplication. Multiplication between these two. These will cancel out. We get y equals 30 divided by the square root of 3. Now, we cannot simplify those because one is outside and one is inside. It's not going to be 10 or the square root of 10. That is wrong. Because the square root of 3 is under the radical, we cannot simplify it with the 30. So our two missing lengths are 15 divided by the square root of 3 and 30 divided by the square root of 3. Great job, guys.